Hello everyone. I'm going to do a little impromptu video to go over inverse square law and our transformers laws. So we did go over inverse square law in class pretty fully, so I'm only going to do a couple things with that. And then we'll get into transformer laws. I'll give you a little extra practice with that. So our inverse square law. Last week I said inverse square law is the way we apply distance and our intensity. The intensity is going to be how many X-rays essentially are hitting our image receptor. So if this is our IR and this is our X-ray tube right here, we know what an X-ray tube looks like, and our X-rays are traveling towards our IR. The further away our X-ray tube is, the less of our X-rays are actually going to make it to the image receptor. Now, if our X-ray tube was closer, one second, I got a new whiteboard here. If our X-ray tube was actually closer to our image receptor, so like this, then a lot more of our X-rays would actually make it to the image receptor. So all in all, the closer our X-ray tube is to the image receptor, the more intense or the more X-rays we will see at that image receptor. And the further away it is, the less X-rays would actually make it all the way to the image receptor. So our inverse square law is just the math behind that principle. Now, the most common formula for our inverse square law is I1 over I2 equals D2 squared over D1, that quantity squared. And these different letters mean different things. So our I1, that is our initial intensity, meaning whatever the initial dose is going to be is going to be this number. So like if they say the initial intensity is 2 MR, that will be the I1 intensity. Our I2 is our end intensity or our second intensity. This is usually what we're solving for. New intensity here. Intensity. Our D1 and D2. D1 is our first distance or our initial distance. Let's do that. And our D2 is our second distance or the change in the distance, new distance. So if it says, hey, we're starting at 40 inches, that would be our first distance or our initial distance, and then we're going to 72 inches or we're going to 20 inches. Whatever the second distance they give us in our math problem is, that's our D2. Now you'll also notice that both of our distances are squared. That's the square part of inverse square law. So really, once we know where our numbers go, as in like which number in the problem is our I1 or our D1 or our D2, it's pretty easy. You just plug them in and do the math. And then it should be pretty plug and chug. I always tell you guys I like to play the game, does it make sense? Because I don't really like math. My game of does it make sense means that if my new distance is longer than my initial distance, then I should expect that new intensity to be a smaller number than what we started with. If my new distance is smaller than what we started with, then I should expect my intensity or the amount of X-rays I end up with to be bigger. So we're going to do a couple problems. We did a couple of these in class already. We're going to keep with that same theme. Let's see here. I'm on slide 13 of the first PowerPoint, and we're going to use the same numbers they have there. So the intensity of radiation at 40 inches measures 2 MR. So in this one sentence, we have been given two things. the intensity of the radiation at 40 inches measures to MR. So the first thing it gave us was our initial intensity, which would be our 2MR. MR is a unit to describe the amount of radiation. Our exposure, our intensity, our dose, all of those mean the same thing. And then our first distance it gave us was 40 inches. So our initial distance was 40. Now, we did a couple of these in class. So I think we did the first one and we did the third one. So we're gonna do the second one, 50. What will be the measurement of intensity at 50 inches? So that is a distance, and that is our second distance. So this would now be 50. So just like in class, what are we now looking for? We're looking for this guy, our new intensity. I'm just gonna make sure the board covers all of that. Oops, sorry guys. Our new intensity. That's what we're looking for. Now, I always make this an X. So I just call that X. Move that over, just like that. Okay, so based on that, we're gonna go ahead and get started. So I'm just gonna plug these right in where they went. So I1, that's our first intensity. That was 2. I2, I always turn it into an X just because it's easier to solve for. D2, our new distance was 50. Just erase all this. 50, and we are going to square that. And our D1, that initial distance we were given, was 40 inches. And that's also squared. So the first thing I do is I square my numbers. The left side of the board is going to be set up exactly the same, 2 over X equals, and these quantities squared. 5 times 5 is 25, so 50 times 50 should be 2,500, because we have 2 zeros. And 4 times 4 is 16, and add 2 zeros to that because we're squaring it, and we should get 1,600. And now we're just going to cross multiply. So 2,500 times X is 2,500X equals 2 times 1,600 is 3,200. Now I have to pull up my calculator on my laptop because I'm using my phone to record here. Okay, so now we have 2,500x equals 3,200. To get this x by itself, we are going to divide both sides by 2,500. These ones will cancel out over here, and then we are going to be left with 3,200 divided by 2,500. And that gives us a value of 1.28 MR. Now, I said I like to play the game, does it make sense? So our initial distance was this 2 here. And I'm sorry, not our initial distance. Our initial intensity was 2. Our initial distance was 40, and we went to 50. So if this is my IR here, this would be, let's say this is 40 inches, and this would be 50 inches. So we went further away. So I should expect that that intensity I started with should be smaller than 2 because we had to travel further than when we started. So when I'm doing these problems or when I'm looking at these problems on my test, if I know my second distance is further away, I should expect my intensity to go down, which ours did. If you are looking at your math problem and 2 of them are bigger than 2, then we could have eliminated those right away. But our ending result, 1.28, is smaller than 2. So yes, this does make sense. We went a further distance away, so that intensity or the amount of x-rays that made it all the way to the IR with the further distance should be less than what we started with, which is what we got. So that's the first one. I'm going to go ahead and set up for another one. So let's see here. All of these ones, besides the one we did in class, which was the 20 inches, they get further away. So I'm going to kind of make one up here, or let me see here. Now we talked about the rule of thumb. The rule of thumb in the inverse square law means that if you go up to slide 11, the rule of thumb says if you double the distance, your intensity will decrease by a factor of 4. Meaning, if we go from 5 feet all the way to 10 feet, if my intensity at 5 feet, so let's say distance, intensity, make a little chart here. This is the rule of thumb. Rule of thumb. So let's say our distance was 5 feet and we went to 10 feet. Well, if our intensity at 5 feet was, I'm trying to think of a number was 12. Let's say our intensity at 5 feet was 12 MR. Based on the rule of thumb, it says if you double your distance, which we did here, then our intensity should decrease by a factor of 4. All that means is if our distance is exactly doubled, we should divide this number by 4 to give us a new distance of 3 MR. There are a couple problems on your PowerPoint that follow that law. Now, on the opposite end, you could reverse this right back. If our distance was 10 feet and we went to 5 feet, if we cut our distance in half, 10 divided by 5 is 1/2, or 5 is half of 10, whatever way you want to look at it, then our distance should increase by a factor of 4. So that means we would multiply our intensity by 4 to get our new intensity. So 3 times 4 would equal 12. So those problems on slide 14 follow that rule of thumb. So we'll practice one of those as well. So let's see here. I think I did the middle one in class. So let's do the first one. If the radiation intensity measures 5 MR at 40 centimeters, what would be the intensity of radiation at 20 centimeters? So our first intensity is 5 MR at 40 centimeters. Now, your distances, it can be in inches, it can be in centimeters, it can be in kilometers if you wanted it to be. They're gonna cancel out. So at the end of the day, we don't really have to worry about what it is, we just have to know how to solve. Our new distance here was 20 centimeters. This is the first problem on slide 14, and we're still solving for x. Now this is based on our rule of thumb. So if we cut our distance in half, we went from 40 centimeters to 20 centimeters. So I should expect this 5 to go up by a factor of 4. So the number I'm looking for at the end of the day is going to be 20 MR. If you're looking at your test question, let's see, and it flows perfectly, and it is you look at it and you're like, oh, that's a rule of thumb problem. I can solve that right in my head without working it out. Go for it. But if you want to work it out to make sure it's correct, go for that too. That's what I always do. So we remember our formula is I1 over I2 equals D2 squared over D1 squared. Our I1 was that 5 MR. Now this 20 here, this is what I'm thinking my end should be. This is me before I even do the math problem thinking, all right, I should expect it to go up by a factor of 4. 5 times 4 is pretty easy, so I'm looking for that 20. I could have solved it outright just like the way I did in my head, but this is the long way to make sure I'm right. Our I2, we're going to make that x. D2 is 20, and we will end up squaring that. And our D1 was 40, and we'll end up squaring that. And then 5mr over x, which I tell you guys this all the time. We can kind of get rid of that mr because it's not going to matter till the end. If you want to leave it in as you do your math, feel free, but you don't have to. 5 over x equals 20 times 20 is 400, or you could do 2 squared is 4 and add 2 zeros. 40 times 40, we had that earlier, is 1600. So now we cross multiply. We have 400x equals 5 times 1600. So 5 times 16, 4 times 16 is 64, so it should be 8,000, I want to say. Let's double check it though. Is 8,000. All right, and then we're going to divide that. We're going to divide both sides, I should say, by 400 to get that x by itself. And then we should end up with x equals 8,000 divided by 400 is 20 mr, which is what I predicted it would be just based on our rule of thumb. You can do the rule of thumb if you see that our distances are exactly 1/2 of each other or exactly double of each other, or you can work the math out, whichever you prefer. Now, we did one where we got closer. Let's do one where it gets further away. We did one of these in class already, which was the middle one, so we're gonna do the bottom problem, which says that our intensity of radiation radiation intensity measures 5 mr at 40 centimeters. So our first two things are staying the same, but our distance changes to 80 centimeters. So we are now making our distance longer. If our distance doubles, we should expect, based on our rule of thumb, if our distance is doubling, then our intensity should decrease by a factor of 4. Right off the bat, what we could do here is we could just do 5 divided by 4, and that'll give us a new intensity of 1.25. That's what I think we're going to end up with, but we're going to do the math to actually figure it out. I'm not going to write the formula out again because we've done it 3 times already, but if you need it, it's just I1 over I2 equals D2 squared over D1 squared. So our I1 is going to be 5. We're still going to use x for our I2. Our D2 is 80, and we're going to end up squaring that, and our D1 is still 40. So get this all nice and pretty. 8 times 8 is 64, so this should be 6,400, but if you're like me, you're going to double check, and it is 6,400. I know 40 times 40 is 1,600, so we're going to end up with cross multiplying 6,400x equals, I think, 8,000 is what we said earlier. 5 times 1,600 is 8,000. Boop, boop. And then we're going to divide both sides by 6,400. 6,400. And that will give us, hopefully, what we're looking for, 1.25. X is going to equal 1.25 mr, which is exactly what we were hoping for based on our rule of thumb. Our distance doubled, so this should have decreased by a factor of 4, which means we divide by 4. We got 1.25. Or you can work it out the long way like this, and you should still end up with what we wanted. Okay, that is your inverse square law, and I will do a couple problems on transformer laws as well.